Okay, in this problem, we're given a maximum and a minimum, and we're supposed to come up with the entire function using those two coordinates. They give us a little bit of a hint that it's a cosine rather than a sine, although it could be answered with either a sine or cosine. I do believe cosine will be easier to link to what we're given here, mostly because of this anchor point that's at the top of its amplitude. So let's start with the easy parts here. We can calculate amplitude, which is our coefficient on the whole thing, by taking half of the total height. The total height is something we can find by looking at the maximum and the minimum, the y values. So we're going to find total height by going -2 minus -14, the difference in y values. Okay, so that's 1/2 times, what we'll get there is -2 plus 14, so that's going to be 12. So half of that is 6. So our amplitude turns out to be 6, which is easy to visualize. The distance from the midline to the peak there being 6. Okay, so we're going to use this as our a value. Next, we can use amplitude and one of these minimums or maximums to figure out midline. Midline can be thought of as the minimum plus the amplitude, or you could do maximum minus the amplitude. Either way will get you to the middle of the wave. So the minimum here is, again, -14. We just used that to help find total height. So -14 plus the 6, that is our amplitude, and we get -8. So we've got a midline of -8. So that's our d value here, will be -8. So for our final answer, we've got 6 for our amplitude, and we've got -8 for the midline. Now, I mentioned earlier that I do believe cosine will be an easier model to go with rather than sine, and I'm just going to echo the reason why for that. Remember, with cosine, when we are contemplating one over the other here, cosine in its parent function status starts at the top of its amplitude on the y-axis. Now I see a point just like that here, only it has been shifted to the right not 2 units, but 3π4 units. Got to be careful there because that dot looks real close to 2 here, but 3π4 to the right. So normally cosine would start right here. This one is starting to the right. So we're going to do this as an x minus 3π4. I'm up in the top right of the screen here as our phase shift. So I'm going to write that down, x minus 3π4. As long as I protect that with a separate layer of parentheses inside the cosine function, that is literally my shift, my phase shift to the right for the whole thing. All we have left to find is the b value, which will help us with the spread, or the horizontal stretch or shrink related to the period here. So b value in radians is 2π divided by 1 period. Okay. Now, there's a couple things we could do here to find period, but I want to keep it simple. We can see that from the points we're given, from an x value of 3π4 out to an x value of 2π is exactly half of a cycle, okay? If we continued with the rest of that curve up to the peak again, that would be a full period. So we want to know what one full period is, but all we know for beginners is half a period. So I'm going to start with what I know, which is 1/2 of a period, which we can calculate using those 2 points. Will be the difference of the big X value, this 2π here, minus the small x value, the 3π4. Okay, So in terms of fourths, you could rewrite this whole thing as 8 pi fourths minus 3 pi fourths, just to get the fractions to talk, and you'll get 5 pi fourths. Now that is half of a period. Okay, so I'm going to put that up here. Half of a period is 5 pi fourths. If I want to get one whole period, I'm going to have to double it. Okay, so to go from a half to a whole, you got to double. So I'm going to double 5 pi quarters. Now you could do that by doubling the top and calling that 10 pi quarters, or you can cut the half in bottom, cut the bottom in half, which is the same thing you'll get from reducing this. So you'll end up with 5 pi halves. That's one way to double it as well. So we're going to use that for our period up here, and now we've got our b value within sight. We've got 2 pi divided by the period will be 5 pi, 2 pi divided by 5 pi halves. This can be calculated by multiplying by the reciprocal of 5 pi halves. And you'll see that the pi's do reduce out, okay, and you'll get 4 over 5. So 4/5 turns out to be the b value that will get this thing to squish down to the right size, or stretch out, I should say. And there is our finished model with a phase shift. I hope that helps.